Good day everyone, this is Jerry from G-XPERT. Okay, so I'm going to try and make this video quickly as possible, short and sweet, and just explain, because I see after, I don't know, 2-3 years, people are still wondering why am I doing what I'm doing. Okay, so let me start off. I've made myself a listing where, according to what I will talk. Okay, so let me start off with the base, the motor and the standard turbo. Okay, so it's a 2-liter, I'm talking about the P series for now. Okay, it's a 2-liter motor that, and then which is not too bad actually. Okay, it's actually a pretty good motor, but the accessory hardware that's fitted to it, the turbo, is too small. It's not producing enough airflow for the motor actually what it needs. Okay, so it's like actually way underpowered. That's why you're only getting 120 kilowatts. But if you are happy with the idea, then I guess that's it. Okay, so everything I'm going to explain to you guys now, none of the things will void your warranty or damage the motor in any sense of the word. Okay, nothing. Okay, it will only improve, I can guarantee that. Okay, so now the base thing that you can do, if you want, if you are happy with it's not giving enough air and stuff like that, then you're happy with that idea, then you can I can just set the turbo mechanically wise right, because mechanically wise it's not set right. Okay, I can do that. I can sort out the EGR and then mechanical wise, and then but mostly the turbo that's will be set right. I know a lot of people will reason, oh no, I've got so many kilos, I don't have any problems and stuff like that, and I'm happy for you. Okay, and I really actually hope that your vehicle will never give you problems. Okay, but from what I've experienced and what I've seen, you are 1 out of 1,000, 10,000 where the vehicle is not giving problems. Okay, so I won't put my hope on the idea that the turbo is not going to give problems. It's going to be it's going to end badly. Okay, so by setting the turbo right, sorting out the setting the turbo right so it's it can never choke. Okay, it's actually very, very important. I cannot believe that China didn't do this, but okay. So that is the first, or the most important thing. So the turbo will still produce the amount of air that is producing, which is not a lot. The motor sucks stronger than what the turbo is blowing, so that's actually bad. Okay, so by setting it right, I'm just getting the turbo to react a little bit quicker to get that turbo lag, shorten the turbo lag a little bit. There is drive-by-wire lag because it's not a cable, and then you got your turbo lag, but you will always have a bit of turbo lag because the turbo cannot flow enough air. It cannot. Okay, so that's why I set the turbo right so it can react a bit quicker through the turbine. Okay, but the compressor side cannot produce enough air in any way. Okay, in higher RPM there is a certain point where it will reach, where it will like very quickly produce same amount of air, and then it will drop again. Okay, that's why you battle to get your boost to stay stable and things like that, because the turbo cannot supply enough air. It's just not possible for him. Okay, then the next thing is boost pipes. So we all know GWM boost pipes, the throttle side, well, it's not actually a throttle, but let's call it intake manifold side. That pipe will go first, and then you will replace it on 2 of those before you will tend to replace the one coming out of the turbo. So the reason, let me explain rubber boost pipes, because when it reaches pressure, and then this is your atmospheric. This is inside your boost pipe. So when you reach pressure, it expands to the max that the pipe can. But the atmospheric on the outside is always trying to push it in. Now this fighting from the outside and the inside will create more heat. Okay, and heat in the intake is bad. Okay, the colder, the more dense your air can be, the more power you can have. If you want to make a very, very, very good upgrade on your vehicle, setting the turbine EGR and putting stainless steel boost pipes. So when the air exit the turbo, there's no expansion anymore. It's just solid and it flows. Okay, there's no fighting it. It just flows easily through the intercooler into the intake side, and then yeah, you will realize that your response time is so much faster. Okay, and the pipes are so much cooler. Okay, if on even on that useless turbo that's on there, if you just improve your cooling system for your intake, like bigger intercooler, air to air, or I will import later on and water to air cooler, that's the best you can do. Okay, you will be shocked how look, your flow will still be bad, so you will reach your boost, and it will still act the way it acts, but because your air is more colder and is more dense, you will have more power, quite a lot. You can gain, well, easily 10, depends on how cold it is, 10 to maybe 15, 20 kilowatts you can gain just from a proper cooling system that can cool your air down. The cooler your air, the longer your motor lasts, the longer your turbo will last, because the EGTs won't go so high. Okay, keep that in mind. So the boost pipes is a very important thing for stability of airflow, and stability also reduces, well, in the pipes there will be zero lag, it's just the turbo needs just to fill up that section, and then it reaches its boost. So you will, with the same standard turbo, you can hold boost a little bit longer, a little bit stronger. Okay, for the same stupid amount of flow that the turbo is giving you. Okay, so boost pipes is actually a very good thing. Downpipe. The only thing a downpipe will do on a standard turbo, standard motor, okay, depends on what type of turbo you go, is it will keep the heat away, get it away from the turbo ASP. So if it's out, if it's through the turbo, it must be out, no pressure back. If there's any pressure back, it will create push up your EGTs, and it will slow down the turbo. So because it exits so much easier and quicker, when you reach your boost, it will keep the boost much easier. Okay, so the downpipe will definitely cause not just your flow to get out quick and get the heat out, but it will also, because now you make life so much easier for the turbo. It can hold, it can easily spool up very quickly with ease, and it can hold as long as it can the 1.5 bar boost, especially when you're under load, if you're going on an uphill or stuff like that, and it can hold it better. And while it's holding it, your EGTs won't go as high if you've got a cat inside. Okay, so a downpipe is a very good thing, getting the heat, exhaust heat, away from the turbo, and when that's away, the turbo can breathe better. Okay, now the next thing is more for, like Mario will tell you, it makes a serious difference. This thing is not making a little difference, but I won't do this if you're still under warranty, because they will battle to get to change the air filter, unless you tell them, don't worry about the air filter, I've got a lifetime air filter in there, and they don't have a problem with that, then by all means. Okay, this cannot actually void your warranty, because it can't. You're just replacing rubber with stainless steel. So your suction side, okay, from your turbo where it sucks and it comes through and it goes to the airbox, that thing I make stainless steel also. Okay, the right size, you cannot go too small here. And when it's like that, when the turbo sucks, now on this stupid plastic thingy that they got in there, and on your rubber side, you guys will see it will go heavy like this. So your flow isn't smooth, it isn't precise, okay? And any movement in the suction side or any struggle in the suction side will create heat before the turbo. And now the turbo takes that heat, air, hot air, and it multiplies it and makes it even hotter, okay? So by building a stainless steel suction side, also reduces heat, but it creates, makes life maybe 50-70% better, easier for the turbo to suck its air through, okay? So the suction side is a big thing actually. It makes one huge difference. The easier the turbo can suck the air, well, the better it's going to respond, okay? And the quicker it will get into boost, okay? So that's also one thing I do, but I did make one a little bit different on Mario's bucky. It actually works nice, but I've got another one that's just pipe, okay? Then the next thing is your air filter. Now, I see there is people that understand a high flow air filter is good and is very important. Remember, your turbo, standard turbo, is so underpowered. Now you got a standard filter that GWM don't like to change, okay? And the more dirtier it gets and the more moist goes into it, the more the turbo will struggle to suck the air through the filter, okay? Because it's becoming worse and worse and worse, okay? It doesn't matter if it looks clean on the outside, but the fibers inside is already clogged up too much, and although it might look good, it won't suck the same anymore, okay? So by replacing the standard filter with a high flow air filter like a K&N style filter that can still filter properly, but produce about 50% more airflow from the standard one, and keep it there with no hassle at all. Now that 50% makes life so much easier. The only thing where you can go, I would say about 80, you will never go, I doubt even, I would say 80 is the max that you can work on for a filter. If you want 100%, you must have no filter, which is not a good thing, okay? So 50% makes a huge difference. So the turbo can get its air so much easier. If you have a high flow air filter and you got a stainless steel suction pipe, you're getting air crazy fast, cold air, and exactly what the turbo or the motor wants, okay? And you will get into boost extremely fast, okay? Your turbo will still overwork your standard turbo. Now, on a flow chart, if you have a look where 1.5 bar boost is on a standard turbo, you are way out of your efficiency island. If I must draw quickly, and then let's say this is your most efficient, and then there, okay? Look at this, okay? So here's your pounds per minute, here's your pressure. Now normally 1.5 bar, I can tell you guys now, it was like 2.5 including atmospheric, but 1.5 bar will be here. So this is typical what the GWM one looks like, okay? Now here's your best airflow section here. You want to go through here and basically stay in that line actually, but you, with the small turbo, you can't, because you are way outside. If you push up your boost on a standard turbo, that's stupidity. That's all it is, okay? So because everything from here is heat. It's not air. It's air, but it's heat. So if it's heat, it's less, there's less oxygen in the air. Okay, so it's a waste of time to push up boost if you're already there. If you're there, it's a waste of time to push it up. And anyway, so if you are here and you push up your boost till here, then it's fine, because you still, the air here is cold. It's not that hot. Here it's just getting hotter, 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 hotter. And the more heat it's getting, the less oxygen in your system, and it simply doesn't help you. So now, if you want to make this work, you need to put a way better intercooler system or water to air system to get this air that's coming out of the turbo, just to make it colder. Okay, because the more heat in the air, the more useless that whole idea is, basically. Okay, you will plateau like extremely quickly. So, but now let me get to the next one, the upgrade of the turbo. Now, my turbos I've designed so it gives a lot of air very quickly. I've broadened the efficiency island as big as I can. You can go max 1.8 bar and you will still be in your best efficiency island. There, you will still be here. Even if you go 1.8 bar boost, you will tend to be there somewhere. 1.5 you should be here. Okay, that's on the upgraded turbos. That's why the air is so cold. So stage 1, stage 2, stage 3. Stage 3 will be in its efficiency island, but because the trim is a bit on the higher side, it will create a little bit more heat than the 1 and 2, but way less than the standard one. Okay, but you will have extreme amount of suction air. You will get into boost extremely quickly, like really quick. Stage 1 and 2 is more torque driven turbos, so the max you will get out of it on a light tune, I'll talk about tune, explain tune a little bit later, will be in the area of 160 kilowatts on a light tune. Stage 1 you should get about, I would say, 150, 152, more or less, yeah. And then stage 2, 160 to 170 you can get. Okay, stage 3 you can get more, you can get 170 to 180, maybe 190. Okay, but this I can tell you guys, it doesn't help you just do a stage 1 or stage 2. It helps, pure logic, it helps. Okay, but you must do a high flow air filter. It just makes sense, because you want that proper turbo to suck through air filter that's like toilet paper, and it's getting more moist. It's going to have to work so much harder, the turbo, and the more harder it needs to work, the more heat will be involved. Okay, so upgraded turbos, I would say your base foundation is, if you don't have money for upgraded turbo, set the turbo right, do the EGR, airflow filter, and stainless steel boost pipes is a good start, a very good start. Okay, later you can do a downpipe. Okay, you don't have to do suction immediately. It makes a crazy difference, but you don't have to do it immediately. Okay, the problem with the suction side, it needs to be built right. If you're not going to build it right and there's a bunch of obstacles in the way, it's just going to create heat. That's all it's going to do. Okay, so it really needs to be built 100% right. Okay, a bunch of, I don't know how to say it, a bunch of faults. It's not, it's stupid. You don't build something like that. It's just creating riffles and heat. Okay, but the most important thing, setting a turbo, do the EGR, high flow air filter, and boost pipes. That's the base foundation. Your turbo is still not supplying enough air, but at least that's a good start. Okay, the second thing you can do, then you can do downpipe. Okay, if you want to, then you can do, but you don't have to, but you can. Okay, it makes a bit of a difference. You're not going to you will feel the difference when you are heavy towed or you go on an uphill. Then you will realize the downpipe, otherwise not. Okay, you might get into boost a little bit quicker, but it's not major. Okay, but the big difference coming when you do an upgrade. Now the only thing that's race orientated upgrade is stage 3. Okay, the rest is torque driven. Okay, so you're getting more airflow. Okay, which you're getting more than the 2 liter needs, but it's not oversupplying it. Okay, but it's getting more than enough. So you guys will realize your 1.5 bar boost, you can get anywhere from 1.5 to really pushing the limits 2000 RPM. Anyway there you will get your 1.5 bar boost, and it will stay there right to 4000 RPM. Okay, and that's power. Okay, but you will realize that the vehicle doesn't want to, it's not like getting weaker because there's not enough air. There's way more than enough air. Okay, and the air is colder, way colder. You don't have to upgrade your intercooler when you do the turbo, but if you do, yes, still it will make a difference. The colder the air, the better the air. Okay, so the upgrades 1 and 2 is torque driven. Okay, there's enough kilowatts. I mean, you can go, like I said, stage 1 you can easily do 150, 152 kilowatts easily. You can still do more, but this is on a very light tune, so the tuners will tell you it's still running lean. So what I mean by that is, from the factory is 18:1 your compression ratio or your air fuel ratio, but when I tune it, normally the lowest they will go in higher RPMs will be around 16.5, around about that area. Okay, you can go low, you can go 15, but if you look at Peter's one, the lowest he went there that matters was 16, I think it was 16 or 16.5. Okay, if they must bring that air fuel ratio on the higher RPM to 15, then you will push 170 kilowatts, no hassle at all. Okay, you don't need so much down under because the turbo, the way I've set it up is to react quickly with the little bit of fuel it's getting. If you're giving a little bit more fuel, yeah, it will react a lot quicker, but just make sure if it's really necessary to give so much air. I would keep it almost on standard till you reach about 1000, I don't know, 2000 RPM. Then you can start changing it, bring it down from 18 to 17 and stuff like that. But yeah, on 1 or 2 you can do that actually no hassle at all, because remember, you're trying to get the turbine wheel to turn, not the compressor wheel. The compressor wheel will turn, but the exhaust gases spools the turbine, not the other way around. Okay, so if the turbine spins right and there's no back pressure in it, the air can go through it, get out, and then it will spool up way quicker. And your compressor just reacts according to how the turbine is driving, turning the compressor. Okay, so but the workout and the design of the compressor wheel is a big thing. The turbine is also a big thing, but the compressor is definitely a big thing. Okay, it's easier to get a better compressor wheel, design a better compressor wheel than a turbine wheel with the shaft. Okay, it's a lot more money, a lot more work, and not everybody have the material to do that. Okay, so so the upgrade is actually a must if you want the full potential for what this vehicle actually can give you. It will not damage your vehicle in any sense of the word. It will actually, in actual fact, it will make it 100 times better. Okay, so your air will be cooler, your combustion will be cleaner and cooler, and then your EGTs will drop quite a lot. Okay, then the last thing is the oil catch can. Okay, so if you take off your rubber pipe and you see how much oil is in that system, that's bad. That's really bad for your for your engine, for your explosion, for your intake. Okay, so an oil catch can, I cannot understand why the manufacturers don't make this a must thing. Okay, it must be a standard thing from factory, an oil catch can. Okay, I just don't understand why they're not doing this. Okay, you don't need oil in your intake, you need air in your intake, and that's it. Clean air, clean cold air. So a oil catch can is a must. It's a very important thing to have. So all that crank ventilation that will be there because of the boost and things like that, especially 1.8 1.5 1.8 bar boost is a lot. So that crank ventilation, there will be oil spillage involved. That will stay behind in the catch can, and when the turbo sucks, it will just be a bit of fumes, but there will be no oil. Okay, you cannot just send the crank ventilation to the catch can. You need to have some suction there to make sure it finds its way. Okay, make life easier for it. Get that pressure out of the crank and out of the inside of the oil side of the motor. Okay, the catch can is very, very, very important. Okay, so all the things that I mentioned to you guys now is there to improve the life of your motor. If you want 500 plus 1000 Ks, then this is the way to go. Okay, that's really the way to go. This is not a money-making thing. This is the way to go. You don't have to do a tune on any of these things that I say. I will not and I will never recommend a tune on a standard GWM with a standard turbo. Like I said, listen to me. Although it's 18, the turbo is not giving enough airflow already. And now and believe me, it's not staying on 18 in any way. It will tend to drop because the turbo cannot supply enough airflow. But now you're giving it more fuel. Okay. Yes, you're pushing up the drive pressure, and the turbo might react a bit stronger, and the explosion also can be a little bit stronger. Okay, not always, but and according to the dyno, you're getting more power. But I've seen so many dyno charts, and the guys come to me and I test their vehicles, and there's no bloody difference. Like, really, there's no difference. I will not and I will never recommend on a GWM a tune on a standard turbo. The turbo is underpowered and it's not supplying enough air. Okay, I will definitely not do a tune if the EGR is still open. Hell no. Okay, so a tune makes sense when you upgrade to a turbo that makes sense for the motor. Stage 1 is way better than standard, way better. It's supplying enough air, well, actually a little bit more for the motor. Okay, stage 2 more than stage 1, and stage 3 way more. Okay, you can rather have too much air on a diesel than a shortage of air. Okay, so when you do a tune on an upgraded turbo, you don't have to go heavy. So normally on a stage 1 from 18 you will go to 20. From stage 2, from 18 you will go maybe 22, 25, maybe more. It depends if you're on the load. Stage 3 even more. So to bring down the air fuel ratio, it's fine then. If you do it, then you will just gain a lot of power, but you won't gain heat, because more air is also less heat, less EGTs. The more fuel is higher EGTs. So if you're on 25 and you add some fueling to it and you back to 16 or 16.5, there will be a lot of power. But that is fine. Okay, it won't damage anything. That makes sense, but not on a standard turbo. Doesn't make sense. I will never talk good about it. Okay, it just doesn't. All the nonsense that I've seen on a tune, on a standard, they just don't last. Okay, so I hope you guys, it's a very long video, almost half an hour. I hope you guys understand it. I hope you guys enjoy the popcorn, and then WhatsApp me, phone me, so I can help you. This is really for the best. Right.